All right, everyone, my name is Joseph Jimenez. I am doing Chapter 9, Problem 48. The question states, far in space where gravity is negligible, a 425 kilogram rocket traveling at 75 meters per second in the positive x direction fires its engines. Show the figure 9.48 shows the thrust force as a function of time. The mass lost by the rocket during these 30 seconds is negligible. Part A is what impulse does the engine impart to the rocket, and B, at what time does the rocket reach its maximum speed, and what is the maximum speed? So first I'm going to answer the first part of the question, and I just drew the graph that they showed. So we have force in newtons for our y-axis, and then we have time in seconds for our x-axis, and we have a triangle, and we know that impulse is equal to the area under this graph. And usually we just do base times height because a lot of the graphs they give us are, a solid square. But because it's a triangle, we're going to use that the area is equal to 1/2 times base times height. So our height is 1,000 newtons, and our base is 30 seconds, as denoted by the graph. And so we're just going to multiply those together to get 15,000 newtons times seconds for our impulse. And we use, of course, and later we're going to use the givens that we were given, our initial velocity and our initial and final mass. But that's what we need just to find out the impulse. So I'm going to pause it and write the second part of the question. Okay, so for the second part of the question is, at what time does the rocket reach its maximum speed? And what is the maximum speed? So right here we can see the force that's being put on that rocket, and you might think that at this peak right here, because that's the maximum force, that's where we get our maximum speed. But that's not the case, because it's just pushing that rocket the whole time. So our maximum speed is going to be reached at 30 seconds. After that, when the rocket's not being propelled anymore, all the drag and friction is going to cause it to stop. And since there's nothing pushing it, it's going to slow down. So this whole time it's accelerating. Next, it says, what is the maximum speed? So first we have to look at the equation that impulse is equal to the change in momentum, which in momentum can be written as mass times velocity. So since it's the change, we're going to get the mass final times velocity final minus mass initial times velocity initial. And because we're already given that in part of the equation, and since we had already solved for impulse, all we need to do is solve for velocity final. So we're going to rewrite it as where am I right here? Okay, we're gonna add this, the initial momentum, to the impulse side to get impulse plus mass initial times velocity initial is equal to mass final times velocity final, and then we're going to divide it by the mass. And we're given the mass, it's the same because any loss was negligible in that 30 seconds. So we're going to get our impulse plus mass initial times velocity initial over our mass final is equal to our final velocity. And when we plug that in, our 15,000 times 425 times 75 over 425, we get our final velocity to be 110 meters per second, 110.3 meters per second. And really we just got that from knowing that impulse is equal to the change in momentum, and then using all of the information that we were given originally to solve for our last variable. So thanks for watching. That was problem 48.